Have you ever stopped to think about a massive server, one packed with parts from dozens of different companies, and wondered how it all works together without just falling into chaos? Well, today we're pulling back the curtain on one of the most critical, yet kind of hidden, technologies that makes it all possible. Let's dive into the server's secret language, PLDM. Okay, just picture a modern data center server for a second. You've got processors from one company, you've got storage drives from another, network cards, power supplies. It's like a United Nations of hardware all crammed into a single box. So how does the system's brain, the main management controller, ask the power supply for its status? Or how does it tell a brand new SSD, hey, you need to update your firmware? Honestly, without a common language, it would be an absolute mess of proprietary tools and protocols. So how do you solve that kind of chaos? Well, you do it with a powerful, shared standard. And that brings us right to the heart of it all. What exactly is PLDM? So PLDM stands for Platform Level Data Model. You can just think of it as a rule book for communication. It's a messaging standard that spells out exactly how different components are supposed to talk to each other for all those critical management tasks. Things like monitoring the system's health, controlling power, and even performing really complex updates, which we're going to get into in just a bit. The best way to think about it is like a universal translator, or maybe a Rosetta Stone, but for hardware. All these different components, they all speak their own vendor-specific dialects. PLDM steps into the middle and creates one single universal hardware language that everybody understands. It brings order to the conversation. And the difference here is like night and day. On one side, in a world without a standard like PLDM, you've got pure chaos. You're juggling dozens of different tools from different vendors, updates are risky and prone to errors, and you're pretty much locked into one vendor's ecosystem. But with PLDM, you get order. You get a single, unified way to manage everything, standardized processes that make updates reliable, and true interoperability. That gives you the freedom to pick and choose the best hardware for the job, no matter who makes it. Okay, so we get why PLDM is so important, but how does it actually work? Let's get into the nitty-gritty of how it builds a conversation between two pieces of hardware. So in the PLDM world, any device that can communicate is called a terminus. It's just a fancy word for an endpoint, really. Now, a terminus can play one of two roles in any given conversation. It can be a requester, that's the one sending a command, or it can be a responder, which is the one receiving the command and doing the work. The whole communication process is this simple, really elegant three-step dance. First, a requester, say a management controller, sends out a request. Hey, Drive Bay 3, what's your health status? Then, step 2, the responder, in this case the drive, gets that request and processes it. And finally, step 3, it sends a response back, something like, my health is 100%, along with a little code that basically says, yep, I understood you and everything went fine. So what do these commands actually look like? Well, here are a few basic examples right from the spec. You've got getTID, which is kind of like asking, hey, who are you? It just gets the component's unique ID. GetPLDM version is a simple compatibility check, and my personal favorite is getPLDM commands. This is basically the requester asking the responder, so what can you do? This is what allows a system to just dynamically figure out the capabilities of everything it's connected to. It's pretty cool. All right, asking for an ID or a version number, that's one thing. But PLDM is built to handle much, much heavier and more critical tasks. So let's focus on one of the most important ones out there, updating firmware. And this is the million-dollar question, right? We've seen these small, simple request and response messages. How in the world can that little system be used to transfer a huge firmware file, which could be megabytes and megabytes in size? The whole challenge boils down to one simple word: size. A standard PLDM message is designed to be lean, mean, and fast. A firmware file is not. You just can't attach a massive file to a tiny little message. It's like trying to ship a car through a mail slot. It's not going to work. So the solution is actually incredibly clever. It's a mechanism called a multi-part transfer. Instead of trying to send the whole car at once, PLDM gives you a standard way to basically disassemble it, send every single part in a clearly labeled box, and then include instructions for how to put it all back together at the other end. That large firmware file gets broken down into thousands of small, manageable packets. And this process is super structured. First, the two components negotiate. They agree on exactly how big each packet is going to be. Then the transfer starts. The first part is sent, Then all the middle parts follow, one after the other in perfect order. Then the final part is sent. And crucially, at the very end, the responder sends back a final acknowledgement saying, yep, got all the pieces, file looks good, we're all set. So how does the receiving component know how to put this giant puzzle back together? Well, it's pretty simple. Each piece comes with a little label called a transfer flag. One piece is labeled start, all the thousands of pieces in between are labeled middle, and the very last one is labeled end. It's a really elegant way to make absolutely sure every single piece arrives and gets put back in exactly the right order. Okay, so we've gone from the really high-level concepts all the way down to the bits and bytes of a file transfer. Let's zoom back out for a second and wrap up with why this all matters so much in the grand scheme of things. When you get right down to it, it's all about the power of a common language. PLDM enables true interoperability, which is the absolute bedrock of modern, scalable data centers. It brings reliability to these super critical tasks that, believe me, used to be filled with risk. And it provides this layer of beautiful simplicity on top of what is an unbelievably complex hardware ecosystem. And this quote just sums it up perfectly. You'll probably never see a PLDM message yourself. It isn't flashy. It's a foundational technology that just works, silently, deep down inside the machine. And like all the best standards, you don't even notice it's there. Things just work, and PLDM is one of the big reasons why. So that's PLDM, the secret language that brings order to all that server hardware. And it kind of makes you wonder, doesn't it? As you go about your day, just think about all the other invisible standards, from the USB port you plug your phone into to the Wi-Fi that's bringing this content to you right now, all quietly and reliably powering our entire digital world.